So here we are given a polynomial function, which is f of x equals x to the fifth plus x cubed plus 2x squared minus 12x plus 8. We're going to find all the zeros of this polynomial. And the way we're going to find zeros is by starting off with the rational factor test. The rational factor test is going to give us possible rational zeros of the function. And this is how we use the rational factor test. A rational factor is in the form, always in the form p over q, where p is a factor of the constant term. In this case, the constant is 8, and q is a factor of the leading term, which is the leading coefficient, which is 1. So the factors of 8 can be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. The factors of the leading coefficient, the only two factors are plus or minus 1. Now we divide one by the other. So start off with plus or minus 1 divided by plus or minus 1 and list all the possible combinations of the numerator and the denominator. So it can be plus 1 over plus 1, plus 1 over negative 1, negative 1 over positive 1, negative 1 over negative 1. And that gives us two possible rational zeros, which is 1 or minus 1. We do the exact same thing with plus or minus 2 over plus or minus 1, which gives us two possibilities again, which is positive 2 or negative 2. If we keep going, we can list all possibilities. And there are 8 possible zeros to this polynomial function. So the 8 possible zeros are plus 1 minus 1, plus 2 minus 2, plus 4 minus 4, plus 8 minus 8. Now here, there are 8 possibilities, and we can confirm which one of these are zeros by plugging in these 8 numbers into the original function to see which one yields a 0 for the value of the function. But plugging in 8 numbers is a lot of work, so I'm going to cheat a little bit. I'm going to graph this function on my graphing calculator and look at a small window with an x minimum of negative 10 to an x maximum of positive 10, because all the possible zeros, all the possibilities lie between negative 10 and 10. So I will know at least roughly where the graph crosses the x-axis or touches the x-axis. So when I graph the function and look at it in that small window, this is what I notice. The graph crosses at x equals negative 2, and the graph touches the x-axis at x equals positive 1. So roughly around negative 2 and positive 1. So I need to confirm that negative 2 and positive 1 are zeros. So I plug in only these two values into the function because my graph tells me that the other 6 cannot be zeros of this polynomial function. So when I plug in negative 2 and positive 1, the value of the function at each of these numbers is 0. So the two rational zeros that I've identified are negative 2 and 1. So let's look at this. X equals negative 2 is a 0, which means that x plus 2 is a factor. X equals 1 is a 0. So x minus 1 is a factor. Now I do know that at one point the graph crosses the x-axis, so the power of x plus 2, because at x equals negative 2 the graph crosses the x-axis, has to be an odd power. It can be 1, 3, 5, and so on, right? But I'm not going to worry about that right now. The multiplicity of x equals negative 2 is odd. The multiplicity of x equals 1 is even, so it can be 2, 4, and so on, but cannot be 6 because it's a fifth degree polynomial. So right now I'm just going to say x plus 2 is a factor and x minus 1 is a factor. I multiply the two to get x squared plus x minus 2. This product is important because I'm going to use this idea. If x equals, if 12 is a number, then 2 and 3 are factors of 12. If I multiply 2 and 3, I get a 6. 6 is also a factor of 12, which means 6 divides 12. So if x plus 2 is a factor and x minus 1 is a factor, then the product of these two is also a factor. So that is x squared plus x minus 2 is also a factor of x to the fifth plus x cubed plus 2x squared minus 12x plus 8, which means that x squared plus x minus 2 divides the given polynomial. So when I do the division, I divide by x squared plus x minus 2. When I do all the work, my quotient is x cubed minus x squared plus 4x minus 4, which tells me that x to the fifth plus x cubed plus 2x squared minus 12x plus 8 is equal to x squared plus x minus 2 times x cubed minus x squared plus 4x minus 4. So what we're trying to do throughout is to obviously find all zeros, and all zeros can be found by factoring the entire expression. So x squared plus x minus 2 is x plus 2 times x minus 1, right? That's how we got x squared minus x squared plus x minus 2. Now x cubed minus x squared plus 4x minus 4 can be factored, and luckily grouping works. We group the first two and the next two. So we group the first two terms and the next two terms. We find a common factor between x cubed minus x squared. The greatest common factor is x squared. And between 4x and 4, the greatest common factor is 4. So we get x squared times, this is what we're looking at, x squared times x minus 1 plus 4 times x minus 1. And now notice that x minus 1 is a common factor between these two. So I factor x minus 1 out to get x squared plus 4. Now I've completely factored the expression. So the factor x plus 2 gives me a 0, which is negative 2. The factor of x minus 1 gives me a 0 of positive 1. I have another factor which gives me again a repeated root, a repeated 0 of positive 1. Notice that x minus 1 times x minus 1 will give me x minus 1 the whole squared, which makes sense because remember we talked about the multiplicity of 2 being odd, of negative 2 being odd, so that's to the 1. But the multiplicity of 1 is even, so that makes sense that it's x minus 1 the whole squared, and then I have x squared plus 4. So far we have 2, 1, negative 2, 1 as the zeros. Now let's look at the last factor, x squared plus 4. If I equate it to 0, then I get x squared equals negative 4, which gives me x equals plus or minus radical negative 4, which gives me x equals plus or minus 2i. So now we have all the roots, or all the zeros, both complex and real. So these two are the real zeros, these two are the imaginary zeros. So we have a total of 4 zeros. The multiplicity of the 0, which is 1, is 2, so it touches the x-axis. The multiplicity of the root -2 is 1, which is odd, so it crosses the x-axis at that point.